Welcome, everybody. I can't see my slides. All right, so here we go. Today, I am going to talk to you guys about something that I cryptically titled the Internet of Shapes. But what that really means is how to craft geometric designs with just pure front-end code. So before I get started, a little bit about me. So as you heard, Brenna O'Brien. You can follow me on Twitter. I'd love to hear your feedback. It's this indecipherable mess of all the consonants in my name. Take note of that. And I am an instructor at HackerYou, which is an independent tech school here in Toronto. So I get to teach people about front-end web development every single day, and that's really cool. So that means I am a front-end developer, which is a great space to be in development. I'm sure a lot of you guys agree. You just get to make cool stuff, and you get to see the results of your code kind of right away. So one of the cool things that I got to make as a front-end developer is this website called csshexagon.com. It's a little web developer tool that allows you to choose your size, color, and generate a hexagon out of just pure HTML and CSS. And you might wonder, how does someone become an expert in creating pure HTML and CSS hexagons? That's pretty easy. You just have to find a designer that asks you to build this. So this is from a real client project that I did a while ago while I was working at an agency. And your first instinct might be just cut out an image. Put a square crop around it, and the pieces outside the hexagon would just be transparent. But that's not really acceptable anymore, and for a few reasons. The first one, which is hugely important, is that web performance matters. Images are the number one culprit as far as slow front-end websites go, and cutting out every single hexagon on that page and multiple pages was just going to be like a performance nightmare with all those transparent PNGs. And then in general, if we create geometric shapes out of code alone, we're going to end up with more performant websites compared to just cropping out images. The second reason why you might not want to just cut out an image here is that the web is full of moving parts now. A static picture doesn't quite describe it. We have animations and interactions and responsive design. And cutting out just an image kind of limits you in having your web page move and fluctuate. And the third reason is a little bit of a selfish one, actually. You're going to do this because it's fun and it's a great challenge. And there's something about trying to create something out of pure code that I just can't stay away from. It makes you feel really great when you're able to accomplish that. And you might just be doing your fellow front-end developers a favor by doing that, because geometric designs are showing up everywhere these days. If you take a look at any popular design gallery, you're going to see things like this, and like this, stuff like that, and even some more subtle variations on that theme. So just to recap, we're going to make shapes with code because web performance matters, because websites have moving parts, because you love a great challenge, and also because everybody loves shapes. So we'll go through a few different techniques today. We're going to get started with a few basic methods that have been around for a while. So that's the CSS triangle hack, which some of you may be familiar with, CSS border radius. Then we'll move on to some more advanced stuff, such as linear gradients, some tricks you can pull with those, CSS transforms, and also SVG or scalable vector graphics. And then finally, we're going to move on to the kind of bleeding edge of front-end web dev, and we'll take a look at HTML5 Canvas and some of the affiliated JavaScript libraries that can really push this into some really cool areas for us. So let's get started with the CSS triangle. If If you do a search for a CSS triangle, you're actually going to find some pages all the way back from 2008. I think that's pretty crazy. Like, I wasn't even building websites in 2008, and this little hack has been around. If you look closely, you're going to see that we're being warned that it might not work in like Netscape 4. So like, careful guys, don't use the CSS triangle in Netscape 4. So the way this works, it's all based on how borders are rendered in CSS. So if you have fat enough borders, you're going to see they're beveled at the edges. And then if you go ahead and shrink that black box, the element inside, to 0 width and height, you end up with 4 triangles, just because of these borders. And then we're going to use a transparent border on 3 out of the 4 to hide the ones that we don't want, and then you're left with a triangle. So once you know how to make a triangle, this is the code for it here. It's pretty straightforward, as you can see, like not a lot of code going on there, just relies on the way borders work. And if you do forget how that magic works, there's a link to a CSS triangle generator where you can like pick out the color and size, and it'll spit out the code for you. So another thing you can do, once you know how to do a triangle, you can do a box with a little notch on it. And you can do a div with like a slanted edge, because that's just a rectangle with a triangle stuck on the side. And you can do crazy things like ribbons. All this just because of the way that borders work in CSS. So next up, we've got CSS border radius. So usually, border radius is used just to kind of round off the corners on stuff, as you might be familiar with from design software. But if you go ahead and increase that border radius to be large enough, you're going to end up with an entire circle. So the trick there is to set it to 50%. That'll kind of guarantee that it's enough to round it off completely. So this is a really common pattern that you see all over the web. And because we've made this in code, I can go ahead and put text in there. And I don't have to cut out an image if I ever want to update the text. It's completely flexible and adaptable. Change of color is just a single line of CSS. It's also really great for making circular cropped images. And it's a really common pattern to see avatars in nice little circles like this. And so nobody on your team has to go through the pain of cropping out everyone's face as a circle. Your ordinary square images are going to work, and one line of CSS is going to turn them into circles for you. So maybe you guys were familiar with those. Getting started, pretty basic. Next up, we have CSS linear gradients. So typically, gradients are just used to do a nice like fade transition from one color to another. But we can do a little tricks by playing with the values in our gradient. So for example, if you put hard stops from one color to the same color and then another color to the same color again, you get this kind of like color blocked effect. So stay with me, not particularly exciting on its own. If you also change the angle of that gradient, you can end up with like an interesting slanted background, which is what I used on that title page of the slides. And then another thing you can do, go even crazier, is take those hard stop gradients and start repeating them, and you can generate striped patterns. So this is pretty like bold, high contrast, so that you guys can see it on the screen. But you can use this with a more subtle variation just to like bring some extra texture and geometric life into your designs, say as like a background or something. This is actually a trick that Leah Varu came up with, or popularized at the very least. And she has a great article about other patterns that you can do just using gradients. So there's a whole wealth of stuff. So where I think it starts to get really cool is something called CSS transforms. So this is going to allow us to move things around in the browser according to 2D transformations and 3D, which we'll see later. So the basic 2D transforms that we have are translate, rotate, skew, and scale. And it's these last three that are going to be particularly useful for kind of generating interesting shapes. Everything's pretty much a rectangle so far, aside from what we've seen. So transforms are going to unlock some interesting variations on that. So first up is rotate. Rotate works by telling something to rotate by a certain amount of degrees. So that looks like that. A great application of this, which I'm seeing all over the web, is to make a diamond shape by rotating by 45 degrees, and that turns it just exactly on its edges. So the code for that looks like this. Again, one line of CSS changes it from a square to a diamond. That's pretty cool. And so once you know how to make a diamond, you can go to town and put everything on your own website inside a diamond, if you so choose. I've also seen video running inside a diamond on this portfolio. And as far as I know, that's just not something you can do with a video, crop it diamond shaped, or at least not very easily. So a lot of flexibility here to put whatever content you want inside these containers. And then there's also more subtle variations on rotate, where those little cross lines in the back here have just been used for a little extra effect. And again, 45-degree rotation onto just like straight lines. Next up, we have skew. So skew is going to apply a sort of shear effect, make a square into a parallelogram. Again, that's just done by applying a certain angle of skew. So here's a cool example of that, where these content boxes have been skewed for interesting effect. And an important thing to note here is that notice the content inside is actually slanting. We'll come back to that in a second. Here's a more dramatic example of skew at work. They've applied a skew transform on like half the page and also added this neat little hover effect so that it shifts around as you're moving back and forth. So remember when I said that that text was slanted when we skewed the boxes? It's an important thing to note when you're working with transforms that content actually does get transformed with its containers. So be careful there. Good thing is that there's a fix for that. What you're going to do is you're just going to apply the opposite transformation on the contents inside. So if we have a 20-degree skew on the container, we'll do a minus 20-degree skew on the content inside to kind of return it to its nice unmutated state. Next up, we have scale. So scale is going to enlarge or shrink something according to like a multiplication factor. And while that's not particularly interesting on its own, you can do some cool stuff by breaking that scale down into its two components. So you can scale individually in X or Y, which amounts to either a stretch or a compression, depending on the number that you're using. So a positive number is going to stretch something out. Sorry, not positive, sorry. A number greater than 1 is going to stretch something out, and a number less than 1 is going to smush something in. So stay with me here, still not particularly exciting. Where this comes in handy is you can start combining transformations together. So if we have this 45-degree rotated diamond, and then we also apply a compression, we can get a like narrow diamond. So the code for that looks like this. You're going to add both your transforms in on the same rule to apply them to the same element. Another gotcha to watch out for with this is that the order of transformations is really important. When you transform something, it actually kind of transforms the entire coordinate system along with it. So you can end up with some funky results if you apply your transforms in the wrong order. So just be mindful of that when you're working with multiples. So once you know these basic transforms, think of them as sort of like Lego building blocks that you can use to build more complex things. Really, like sky's the limit. Whatever you can imagine, you can put stuff together. So Simple example, if we take two skewed boxes, smush them together, we get this chevron shape. A more complex example, and how I ultimately ended up making those crazy hexagons, is to take a rectangle and two narrow diamonds and composite them together. And this is also an example of that counter rotation technique that I showed you guys to get those images to all stay upright. So once you get comfortable with 2D transforms, you can get even crazier using 3D transforms. So in addition to X and Y, you now have a Z axis to transform about, which is sort of in and out of the browser plane. So you get stuff that has the illusion of kind of tilting back and forth. The syntax for that is you're going to specify X, Y, or Z, or use the shorthand rotate 3D syntax, where you can do all three at once if you're doing multiple transforms. So there's a really great tutorials available online about how to get through 3D transforms. This is a sort of small example of how some of those affect things. So like translating in the Z-axis sort of has a zoom effect almost, because it's coming towards you or moving backwards. Where I think it gets cool is those rotate Y and X that kind of like sends it in and out of the browser. So a great application of that is these portfolio pieces that have been put on a slant here just for sort of extra artistic effect. And then you can start piecing that stuff together and make entire 3D solids in the browser just by using all those 3D transforms. If you want to add like an extra layer of fun to that, you're going to start adding transitions and animations. So we can get really cool stuff like the card flip technique, where we're using 3D animations in conjunctions with CSS transitions on hover to create this flipping in and out effect. And you can go even crazier. I've seen stuff like this. I'll just leave that there for a second because it's kind of mesmerizing to look at. This is by someone called Anna Tudor, who has a lot of really great stuff on CodePen as far as geometric CSS goes. So next up, we have a newer technique called SVG. So that stands for Scalable Vector Graphics. And what does that mean? So vector is kind of the important thing there. Unlike your traditional raster-based formats like JPEG and PNG, SVG is resolution independent. So it doesn't get pixelated when you blow it up because it's all defined by the actual path of the shape. So here's an example of a nice use case for SVG. Kind of hard to see here. This is 24ways.org. If we zoom in on the background, they've got this interesting pattern going on with these diamond shapes. And if you peek around in the source code, that's actually an SVG that's just been tiled over a colored background over and over again. So I was able to zoom in and get a nice crisp image there. Compare that with the same pattern as a PNG zoomed in, and you get this like gnarly fuzziness. So SVG is a really great choice to use when it comes to all our like Retina displays and stuff. The iPhone 6, everyone's like, make your 3x assets, and I'm like, just use SVG. So it's gaining a lot of popularity on the web, so it's definitely something I think worth investing in at this point. A couple different ways that you can include SVG files in your stuff. Number one is just to link it as you would any other image file. So where you would put a JPEG, throw in an SVG, it's going to render the same. The cool thing about SVG, though, is that if you take a look kind of like behind the scenes and you open an SVG file in a text editor, you're going to find that there's actually just a bunch of XML under there. So there's code that makes up this thing, which means that we can also just include it directly in our HTML using the SVG element. So this example, it's just kind of step through some of this stuff here. There's a width and a height attribute that actually size the element. And then there's this unitless view box thing, which just sort of like an artboard in Illustrator, if you're familiar with that, defines the area that you're drawing in. And notice that kind of everything inside has no pixels on it, because that's that resolution independence. We're just going to scale it around with the width and height attributes. So right out of the box with that SVG element, there's a few basic shapes that we can create with their own child elements. So there's a circle, an ellipse, a rectangle, a polygon, a line, and this thing called polyline. So all of these can be thrown in right in your code, and you just have to specify the coordinates of how you want that shape to render. So as an example, our circle, we're going to say that it has a center at 50 and 50 and a radius of 45, centered within that 100 by 100 view box. And then a line, you're going to specify an XY coordinate to start and an XY coordinate to end. And that goes pretty much the same for the rest of those. So circles, squares, no big deal. We know how to do that already. There's this other really cool SVG element called path that you can use to define like anything you want. So this is an example SVG path of the Star Trek insignia. Only problem with this is looking at the path element is kind of like staring into the matrix. And don't know about you, but I would never guess, looking at that code, that it rendered as this. So thankfully, there's a couple ways around that. You don't have to author your paths by hand. You can work with vector editing software, and there's actually an export to SVG option for you. And then you can look inside that file and just go ahead and grab the code. There's also a couple of really helpful libraries that we can use to work with SVG. One nice, really lightweight one is svg.js that has its own built-in stuff for drawing some basic shapes and manipulating SVG. Another kind of more robust library with more backwards compatibility as far as browser support goes. I believe Raphael supports IE8, whereas svg.js does not. So it's a bit heavier, but Raphael is also really good for kind of programmatically generating stuff. So here's an example. Some of you, I don't know if anyone knows Rich Gilbank. He's a Toronto area developer. He made this with Raphael, which is sort of just automatically generated all in SVG. So when it comes to SVG, we have a few different options for coloring it in. It doesn't exactly work the same way as background color in CSS. What we're going to do, because these are vector shapes, is we're going to use fill and stroke. So fill is the kind of inside of the shape. Stroke is the outline. So you can do this as attributes on your SVG elements and also through CSS. Not crazy interesting in my mind. You can actually fill SVG with other SVG, believe it or not. So there's this thing called pattern fills that allows you to define a pattern in SVG. So we have this polygon shape here, and then we're using this defs attribute and a pattern that contains another polygon that's used to tile around the shape. And the sort of secret sauce there is that it's linked up using an ID. So the pattern has an ID, and then the fill is referencing that ID. You might think that's pretty cool. I think that's still kind of boring. Where it's going to get even more interesting is you can do pattern fills with gradients. How cool is that? So put that to good use. This aeronaut site, that whole big slanty div is one giant SVG shape that uses a gradient fill on it. And if you want to get really creative, you can do pattern fills with images. So same thing, slightly different syntax, but we're going to link it up with an ID as well. you guys haven't guessed, a bit of a Trekkie. So a more practical application of pattern fills with SVG is this Keras Creation portfolio site. So returning to the diamond motif again, but this time we've got it rendered using SVG, and the images in the portfolio items are showing up using that pattern fill technique. So a kind of cool advantage of using SVG over transformations here is if you were to visit this site, you'll see that the outlines of the portfolio diamonds sort of animate in on page load. So we have a lot of flexibility when it comes to animating SVG. Because these paths are defined by vectors and numbers, it's really easy to tap into that. So a couple big techniques for animating SVG that I like. The first one is morphing shapes from one thing to another. So there's this pretty new technique. Actually, before I get to that, take a look at this site here. I'm going to switch over. So as you scroll down the page, that SVG shape that we saw earlier moves around and morphs its shape for a really cool effect. So if you open up your DevTools here and take a peek, you'll notice that they're just changing a couple of points on the path, which is really cool, to create that whole radar sweep effect. There's also this really new thing called, I don't know even how you say it, SMIL, which seems to be broken. It's supposed to morph from a square to a diamond. Unfortunately, it's kind of wonky right now. So that stands for Synchronized Multimedia Integration Language, and it allows you to define animations right inside SVG using this animate element. So again, you're going to be specifying different points on a path to kind of shift in between, to morph in between. But this was took me a long time to figure out, had to sit down with graph paper and stuff to figure out all these points to switch from each other. So it kind of feels like that good old path thing again, where I'm just I'm looking at the matrix. I don't know what to do with this. I don't want to come up with this myself. And I would not blame you guys for thinking the same way. So lucky for us, there's a lot of stuff that can help you out when it comes to SVG. Adobe released not too long ago this amazing library called Snap SVG that's specifically made for animating SVG elements. So an example of something you can do with Snap SVG is on hover, these little guys kind of morph from a ribbon to a chevron or something like that. The other technique that I know about for animating SVG is to make sort of animated line drawings with it. So this relies on a couple interesting properties that SVG has. These weird attributes called stroke dash array and stroke offset. So these are kind of weird to get your head around, and the animation technique is a bit of a hack. So what we're going to do is this stroke dash array allows you to specify the length of colored and blank dashes. So we're going to do a little trick where we make the colored and the blank areas as long as the entire shape. And then we're going to use this stroke dash array offset to kind of dynamically shift that around. So it has this effect here of the shape drawing itself. If you're interested in that, there's a really great tutorial linked. I'll put my slides up at the end of the talk. So you can do some cool stuff like this website, where as you scroll down the page, the whole website sort of draws itself in. And so this is all done using SVG. I think it's pretty cool. Again, if you're not fond of doing all those computations yourself, there is a pretty cool plugin called Lazy Line Painter. What this does is it'll allow you to upload your own SVG file And then it kind of spits out some like JavaScript config that will allow you to configure the animations of how the path draws itself. So that's pretty cool. So finally, we have HTML5 canvas. So this is a really neat, like pretty new technique in the front-end dev world. And it actually starts pretty basically. We're going to start with the canvas element. And it's just a regular HTML element that we're going to throw a width and height on. If my screen were not all blue, you'd see it's just a blank white box. But then we're going to paint on it with JavaScript. This is the fun part. So simple canvas example to get started with. You're going to go find your canvas with JavaScript. You're going to have to declare this context to say we're drawing in 2D. There are some 3D canvas implementations, but we're not going to get into that today. And then there is like a drawing method to make a rectangle, this fill rect. And we've also done fill style to specify what color I want to fill it with. The thing about canvas, though, is the rectangle is actually the only shape that you can draw with its own method. For everything else, you're going to have to use these drawing methods. Think of them as sort of, I guess, like sending commands to like your paintbrush. So we have a begin path and close path to bookend the drawing process. And then you're going to have to use a combination of moving the pen around, drawing lines, and drawing curves. So as an example, this is drawing the Pac-Man shape in Canvas. So it's made up of a combination of an arc and a line. And just a note here, I've used begin path. I haven't used close path. If you fill a shape, it automatically closes it off, which is kind of cool. Still kind of boring, in my opinion. You can only get so far with like these basic lines unless you're like Path Rain Man. So where Canvas starts to get interesting is that we are now in JavaScript land, and JavaScript land is where browser events live and user events. So we can combine Canvas with events and do really cool stuff like responding to user input. So this is a fun little example where as you scroll up and down the page, you're going to see the canvas sort of fills itself with different colors. Here's another one where this like particle spewer just follows your mouse cursor around. And then if you really want to go crazy with Canvas, there is luckily a wealth of libraries available to you guys to push that further and help you generate some of the more complex stuff. So a quick rundown on some of these. If you are into or curious about drawing like isometric shape projections, which is sort of rendering 3D stuff in the 2D plane, there's two really great ones called Isomer and Sheet Engine. They'll do kind of like shadowing and stuff for you. Sheet Engine does like collision detection. This is a quick demo of Isomer where you get your own like primitive method to draw like a cube, which is really cool. Way simpler than that would have been in pure Canvas. If you guys are into data viz at all, D3 is sort of the go-to. I believe there's a talk on that sometime later in the conference, so check that out. This is an example of a cool Canvas thing. So this is a data viz company that has done their entire like background with D3, where they make these kind of like constellations. This is my favorite part. That's what I was waiting for. There it goes. If you're coming from the Flash world, there is this Create.js suite that comes with its own Canvas library, as well as a tweening library and some audio APIs. So it's kind of like a nice transition if you're moving from Flash to doing like pure HTML stuff. This is an example of that site that is using Create.js, where they've got like a lot of interesting like geometric animations going on, and there's also like some subtle, where did they go, like parallax effects between the different layers. So what they're doing here is they're actually, they've taken 3 canvases and they've layered them on top of each other, which is something you can do. And then finally, 2 of my favorites here are really heavy on the vector drawing and animation side. So if you're like into Illustrator or just like think that this stuff is cool, check out Paper.js and 2.js. So, no, come back. Here's a really cool example made with Paper.js where the whole background is like canvas and they're using the mouse as a sort of like light source that shadows things as you move around on the page. This is a really beautiful, subtle implementation of Canvas using Paper.js as well, where these little shapes just kind of float around in the background. So, you know, I talk about performance. You can make like a really crappily loading like monstrosity with Canvas if you go too far. I think this is a great example of using it tastefully and like performantly. This one's pretty cool. This is 2.js at work. So this is like you guys probably can't hear that. I don't think I have audio, but it's just this like interesting geometric visualization of going along with music. And so that's all rendered using 2.js and Canvas. Oh. And if you heard where it kind of like glitched out there, you can actually click and on the screen to sort of like mutate it, which is really cool. So finally, I don't know if you guys are on the Wi-Fi or not, but do it now or at some time in the near future. This is one of the most like joyful things on the internet, also created with 2.js. I'll leave it as a bit of a surprise, but go check out patatap.com at some point today and just have like a wonderful time with it. So we started with this teeny little triangle made out of borders, and we've come all the way to generating like rich interactive experiences in Canvas. And all that in the span of 5 years. I can't like, it's incredible like what we're able to do in the browser alone, and I can't wait to see where it goes next. That's all I got, guys. Thanks. I think we probably have some time left for questions if anyone's got any. No one? At the back there? Or sort of back, 2/3 back? Yeah, so the question was, when animating 2D transformations, do we find better performance by applying a 3D transform? So this is actually an interesting trick that someone came up with where even if you're not doing 3D looking stuff, you can sort of force a 3D transform on the browser. And what this does is if there's a GPU available, it's going to kick that in to be able to render your graphics rather than solely relying on the CPU. So sometimes you can end up with better performance, especially on like smartphones where the GPU is readily available to the browser. Great question, thanks. Anyone else? Right over here in the middle. Yeah, so almost everything that I've shown you guys is good back to IE9. The one glaring exception is that SMIL animations. That unfortunately is not supported in IE at all in any version, so I kind of like approached with caution. Maybe use like Snap SVG to do that. It's a fun thing to play around with, and maybe we'll see it someday. But yeah, everything else, you're good back to IE9. If you're in the unfortunate situation of supporting IE8 still, I tend to go the like progressive enhancement route. probably a lot of these things that you're doing are sort of like enhancements, embellishments. It's okay for someone to have a square image instead of a circle image if they're browsing on an older browser. And I think it's worth making the compromise to sort of help push the web forward. Thanks. Again? Yeah, I'll tweet it out. Someone's asking a link for slides. I'll throw that up once I'm off stage for you guys. And they're all done in HTML and CSS, so you can like look at the code for all the things that you see. At the back here? Sorry, to transform what into SVG? D3, so he's asking about populating SVG dynamically in real time with data. Even though I mentioned D3 as a canvas library, it actually also supports SVG. So that might be a good one to look into as far as dynamically generating stuff. Another question at the front? So the question is like, how common is IE8 still? Like, so a while back, Google and like Facebook adopted a policy of supporting 2 major versions back of any browser. So for IE, we're on 11 now. That would be like 10 and 11. I think Google only supports. I don't know what the exact numbers are right now. IE8 is dropping, but as you say, it's mostly kind of like corporate infrastructure, like that is like holding that back. So probably not the organization you mentioned solely, but it's sort of like a greater problem at large where it's a big deal to update like everyone's computers. But like I say, there's always kind of ways around either using like a JavaScript library or just like letting things fall back to a less fancy state. So you can make it work, I think. All right, I think that's all the time I have. So if you have any other questions, send me a tweet or find me around. I'll be here for the rest of the day. Thanks, guys.